Hey everybody, I don't know if you can see me or not. Anyway, expect to have an exam tomorrow like I warned you. When we did this was the Check Your Understanding worksheet from September 10th. I believe that was Wednesday. Yeah, Wednesday. Just kind of go over this. We're going to basically be able to, one, for each given measure, sketch the angle and standard position, okay? Be able to sketch angles in standard position, whether it's positive in degrees, negative, or positive or negative in radians. Don't worry about explaining. Just know how to convert each degree measure to radians, okay? Go from radians to degrees. Find coterminal angles, okay? Whether in degrees or radians, okay? And here, be able to build your triangle and use Pythagorean theorem. Once you do that, you should be able to find anything I ask you. If you've got all the sides labeled, your H, O, and A, you should be able to find secant, cosecant, tangent, cosine, sine, etc. Here, you'll be given, in this one, you're given an angle and a measure and find the coordinates, okay, using your SOHCAHTOA. If you're given hypotenuse and angle, you can solve for the adjacent, and then you can do it again. Okay, let's take a look at what that entailed. Okay, here's angles in standard position. Here's 50 degrees. Remember, we start off on the initial side as the x-axis and rotate to the terminal side. Here's a negative 150. This is, I made an error on. Notice I only made 1, 2, 3, 4, 5. This is supposed to be 5, 6. I ended up making, this is actually, my drawing is wrong. It's 4. This is 4/5. 1, 2, 3, 4. Okay, this is 4/5 pi. I should have, if I wanted 5/6, pi should have been broken into 6 slices. So note, I put this a note on the website that I made an error on 1b. Okay, all right, this is negative 9/4. Notice the denominator is what I broke up pi. Pi is just half a circle. This is 2 of those, 2 candy bars, right? 1, 2, 3, 4. But we're going in the negative direction. Notice this is going to be 4 goes into 9 twice with a fourth left over. So it's a negative 2 1/4. So notice here's a pi, here's another pi, and I've got that extra fourth, and we went in the negative clockwise direction. Okay, this is done properly. Like I said, I divided each pi into fourths. Okay, all right. We talk about going 2 radians, multiply degrees by pi over 180. Whatever you're going to out of this conversion ratio goes in the numerator, so pi. All right, so look at 3. This is a review of what we did. 135 degrees times pi over 180. Just leave pi alone. Just simplify your fraction, and that's 3/4 pi. Okay, negative 60. That's negative 60 over 180 is a negative 1/3, and then it's negative pi thirds. Okay, you can review all this online. Here are my to go from radians to degrees. Degrees is up top. Okay, so here's pi fourths times 180 over pi. The pi's cancel out, and just simplify in your calculator 180 over 4, 45 degrees. Here's negative 3/2. Okay, all right, negative 3/2 is pi. I'm converting that to 1, 2, 3. Negative 270 degrees, okay? So 2 goes into 180. The pi's cancel out. 2 goes into 180 90 times, and 90 times negative 3 is negative 270, okay? All right, that would be all the way up here. It's coterminal with, here's negative 90, negative 180, negative 270. That'd be coterminal with a positive 90 degrees, okay? All right, so this is multiplying, this is all review, multiplying by 180 over pi to go to degrees, okay? All right, coterminal. This has been kind of, see if I can spread this out a little bit, okay? Here you're given a range. You need to get a coterminal in degrees, and you're going to, in degrees, you're going to, I wanted 0, you wanted to get between 0 and 360. Okay, so notice here's 1325. We're going to subtract full revolutions to get coterminal angles, and we're going to keep subtracting 360 till we're in that range, in this case 245. Here we started off with a negative 460, so obviously we need to add revolutions. We're going to go counterclockwise, and I add 360, negative 100, still not in the range, and we add it again, and I get 260, okay? This has been the trouble spot with people's weakness, students' weakness on common denominators. But 19/4, I sliced pi into 4 slices. So if I have, every pi is broken down into 4 pieces, fourths. So if I have 2 pi, that's 8/4, okay? All right, so 8/4 represents 2 pi, okay? So I need to be between, on these problems here, between 0 and 2 pi. So here I'm subtracting full revolutions of 2 pi going clockwise, 2 pi, 2 pi, okay? So minus 8/4 gives me 11/4. That's still not between 0 and 2 pi. So 11/4 minus 8/4. Notice this numerator, the denominator stays in increments of fourths, and I finally get 3/4 pi, okay? Here, we sliced pi into halves. So if I have 2 pi, that means I have 4 halves, okay? I'm adding increments of 4 halves pi till I got all the way within to 3 halves. We talked in class about using mixed fractions. This would be 2 goes in there, negative 18 times, it's negative 18.5, and I can just add, in that framework, I can add 2 pi and get to negative 16.5, negative 14.5, negative 13.5, 12.5, sorry, I got to stay even, 10, negative 8, negative 6, negative 4, negative 2.5, then negative 2.5 pi, negative 1/2 pi, finally plus another 2 pi gets me to 3/2 pi. All right, wasting time. All right, so here I'm given a point, solve for the hypotenuse, 5, you got an xy coordinate of 5, 12, okay? Pythagorean theorem, solve for 13. Once you do that, you can solve for anything. Once you build the triangle, okay, solve for anything. Now, same thing over here. Here you've got one that was a negative 611, and Pythagorean theorem, you get radical of 157, okay? 6 squared plus 11 squared is 157, that's prime. All right, just be able to do that, review this. Here's one 9, where you're given the hypotenuse and an angle, okay? Solve for the point, okay? Solve for x, and then later solve for y. I've got my hypotenuse, I've got the angle, so let's solve for the adjacent. That would be cosine. Okay, so we set up cosine equals adjacent over hypotenuse, and you can use algebra or the cross product and solve for x. Do the same thing for y now. Now you're doing sine. Okay, sine is y over 7. Okay, all right. Here's the tricky part. Be prepared to have angles in quadrant 2, quadrant 3, and quadrant 4. Okay, the triangles you build will be the difference between the angle itself and the x-axis. Okay, so if you're in quadrant 2, build a triangle that is 180 minus that angle, and then build that triangle. Okay, so if you're given a 140-degree angle from here, okay, 180 minus 140 would be 40, and this triangle will have a 40-degree angle, solve for x and y, and you'll be given like the hypotenuse, okay? If you're in quadrant 3 and your angle comes all the way down here, it's your angle minus 180 will give you the angle for your triangle, okay, to do your SOHCAHTOA, okay? All right, review 9A and B. Okay, so your test is going to be like that. Okay, here you're given a 30, 60, 90 triangle. This was kind of easy. You're given 5 and 5 roots. I think you're given same type problem here. I kind of worked it out using the 30, 60, 90 rules. Okay, so this is what your test is going to be like, but be prepared maybe to have angles in all the different quadrants. Be able to build your triangle based on if your angle ends in quadrant 4. It could be 360 minus that angle would be the angle you build your triangle with to solve for x and for y. Finally, it's 9 minutes. Make sure your angles or your sines and cosines, your x's and y's, reflect the quadrant. Plus, plus, minus, plus, minus, minus for quadrant 3, and plus, minus for quadrant 4. All right, see you tomorrow. It's 10 minutes.